that go slow. I cannot consume that. So that concept is the back pressure.
Yeah, back pressure, like it's your, it's a, I think, pattern which can be used in this kind of problems.
So first, actually, go that how your broker is going to get implement. So I think here they will implement two separate component, and they will keep it somewhere in memory buffer, or I mean on the disk where you have the space. You can so these two are the two separate entity. So broker is just once it's actually right, it will know that okay, message will persist and someone will take it from there.
Okay.
And the consumer will take it from there wherever the broker actually written that message, maybe a database or a flat file or whatever.
Okay. Sorry, can you explain that once again? I think I'm
What I'm saying that the first we had to figure out that how this broker will get implemented, where this broker will write the message. Do we have a finite set of buffer or unlimited buffer?
okay. Like you mean make it bounded somehow?
Yeah, if it's bounded, then definitely, I mean, there should be some way to control that. If there is no room in the buffer,
Uh huh.
broker has to wait.
But
So for that, you were saying back pressure we can apply.
Yeah, that is one thing, but I mean, whatever you call it, it's a back pressure or whatever you name it, it doesn't matter here. But somehow a broker will get to know that I have to wait. There is no room.
but how would that? So my question is, I think I get it. What you mentioned, Praveen. My doubt is how would that affect the batch size? Like in terms of batching, how would that work out?
So I don't follow you. What do you mean by batching here?
So let's say if
Give
you are
me some
sending,
context.
if you are sending messages in a batch, uh, few of them got consumed, and few of them are still in the buffer. Okay. Would the acknowledgement be given like loosely for the message which are consumed, like for the offset, or would the acknowledgement be given in a batch, like the batch that has been added to the buffer?
So the question to whom you have to give this acknowledgement.
To the broker, basically in terms of offset, like we have to advance the offset, right? Like because these messages are got messages have been pushed by the broker to the consumer. It needs to advance the offset to whichever, like the message that has been, last message that has been pushed out of the broker to the consumer, right?
So, okay, so let me reinterpret that and try to understand that. So you're saying that, I mean, the consumer read the message in a batch, and I believe that to optimize the read path, so it put that in the cache and then start consuming. But some of the message they consume and some of due to some issue, whatever,
Yeah,
they can't process those messages, right?
correct, correct.
Right. So now they will actually um, write the offset. What is the as the message is coming in sequence? Maybe the lowest message they have processed so far. They will maybe write the offset up to that point. It, I mean, that's in implementation detail. Uh, so I don't know how they implement it, but this is how I need to visualize that. So you have to you have to write that offset. So like if these messages in a batch they read from 1 to 10 and they process only uh, X number of messages, they write the offset for these messages. That could be so these messages in from 1 to 10 they process message 1, 2, and 7, 8, 10, 10,
Mm-hmm.
right? Not in sequence, right? So maybe they just keep track that what are the messages they have processed. They read up to this offset, and up to that offset they process only 5 messages, and out of those, and what are the remaining, they will keep those messages. And now in the next batch they know that what 5 old message they have to read and what next 5 message they have to read.
Okay. So far I am
I don't
following.
know if
Yeah.
I'm making sense to you here or not,
Yeah.
but
So when there is just one consumer group, I think that completely makes sense to me. What if there are multiple consumer group? You mean to say the offsets would always be maintained per consumer group?
yes. So it's just
Okay.
like, I mean, what was the real life example I can give you? I mean, yeah, not the real life, but let's take a very basic example, and I'm sure that everybody can easily map that. So we do have a flat file, text file,
Yeah.
right? And two processes actually wants to read the same file.
Mm-hmm.
They can open this file in share mode, right?
Yeah.
And they can start reading. And both your OS actually provide you the functionality that okay, both can actually keep track that what is the the last pointer, where is the last pointer in the file. Up to that point they have actually
Correct.
completed the processing. Both can work independently, right?
Okay.
And once you're done, so you can write that information, say like okay, I completed the file up to offset 1000. So it will write that information in somewhere, either in some database or another flat file. And another process has its own file where it will write this offset. And when they will start again, they will read their own offset, read the same shared file, um, seek to that offset, and start reading from there.
Now you mean to say this last part you mentioned, that is per consumer level, right?
Yeah,
Not the
so
partition level, because if a particular consumer is trying to maintain its own fat file for writing the offset, then that makes sense to me.
yeah.
But if the consumer groups are trying to share the file for writing the offset, then I think we have a problem, right?
So if you are talking in the context of this consumer group, in the context of Kafka, so I recall that, though I have not used the Kafka myself in my life, but what I recall that in a consumer group, only one consumer can read from a particular partition, not more than one consumer can read from same partition within a consumer group.
Correct.
So, so then what is the problem here?
So my question is related to the offset. That basically my question is, would the consumer group maintaining its own offset, or with will both of the consumer, like let's say we have two consumer group, will the offset be maintained for the whole all the consumer groups together, or will the offset be maintained per consumer group?
It should be per consumer group.
Okay. Okay.
Yeah. Otherwise, there is no point. I mean, there will be a mix and match. So that is per consumer group. It could be possible that, I mean, though within a consumer group, you have only one consumer, it's reading from X number of partition, the same consumer. So they maintain their own on offset.
Okay. Okay. Understood. Yeah.
Yeah.
So yeah, I think Bhavna, your point could be correct. What you mentioned. Yeah. So even like I don't have much context on I didn't have the context on this, but yeah, as you mentioned, even in push model itself, uh, even if it fails, it could actually try to then push it again.
Yeah. Message loss in Kafka, I need to read it more though.
Yeah.
How it can happen, in which situations. Yeah.
Yeah. Yeah. Okay. Yeah. Uh, in Nitika, any more questions? Anyone else, or if you have,
Can we summarize what did we discuss? So are we trying to say if in the push model, if broker is sending 20 messages and consumer one is only able to consume 10 messages, so rest of the 10 messages it will try to it will retry to consume those messages again?
yeah. So the summary is the messages won't get lost even if it dies. It will try to retry the. It will retry the rest of the messages.
I think I would say here that, I mean, from the book point of view, looks to me that what I'm reading, you are showing on the screen,
Mm-hmm.
the author yet actually not reach up to the point where you are actually thinking that it's Kafka.
Makes sense. Makes sense. Okay.
Okay,
Yes,
Okay.
correct. Yeah.
makes sense.
Yeah.
So right now the author is actually trying to explain that very basic system. You
Mhm.
have some producer on one side,
Makes
and
sense.
then you have something in between, and then you have the consumer on the other side.
Makes sense.
So my
Yeah.
my suggestion here is that, I mean, don't make a strong assumption like everything is Kafka.
Yeah.
Go with the text. What do you see? And just think like Kafka is one thing. It's not a message queue, though. Kafka is not really a message queue actually. It's just a log file where you can, I mean, replay and use like a message queue.
Yeah.
But here, whole design looks like a Kafka only, right?
Yeah.
So why Kafka can be the distributed message queue? Is it not? Is it not right?
No, actually, in the I think the starting also they mentioned that
Hmm.
Kafka is a event streaming platform.
Yeah, event streaming. That's right.
No,
But which distributed key? What is the queue name? Whatever they are trying to explain.
no, any queue. I mean,
Yeah.
it's not just the Kafka. You can implement, if you go follow these principles, you can implement your own queue.
So generic queue. Like how we can design any generic queue. Is it okay?
So this is the generic queue. They are trying to explain what are the problems you will have when you have to implement a queue, and then what are the constraints, how you will actually solve those problems.
Okay, okay.
So from start, don't make assumption that this is Kafka, right? So the page what we were reading, that we were not even close to that.
Makes sense.
Yeah, thank you. Yeah, that's a good point. Actually, I was
Yeah.
also assuming Kafka only.
Yeah.
Yeah.
So don't yet. I mean, of course. I mean, I think when you will reach up to the end, so then author will actually take you. This is the way author is actually taking you to reach up to the end product.
Correct. Okay, sounds good. Yeah. So let's maybe try to cut down the discussion on this part. It's too premature. So yeah, apart from this, any other doubts? Nitika, I think you were asking some doubts. Anyone else has any doubts? Also, can I go ahead and start the recording? I think we are having a good discussion here. So
It's already 7.
yeah, yeah, we can actually read
Recording is
for
on.
10-15 minutes more if you guys are okay. At least to yeah. Is that okay? Like yeah, let me know. I'm open for like dropping off if anyone has any.
I'm fine.
Okay. So let's at least cover this pull model. Read up the pull model right away till the state storage, or we can stop after the state storage. Okay. Pull model. So after these, do we need to go to these pages?
Yeah.
Okay. So this one here, right?
Yeah.
Okay, sorry. My bad. I think these looks like longer ones. Consumer. Yeah, there are more topics here.
This is the second one.
Okay.
Yeah, this is the first page, and then
This is second,
yeah.
and this is third. Okay. 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 Let's maybe at least complete the pull model and then stop then. Okay. Pull model pros. Consumers control the consumption rate. We can have one set of consumers process messages in real time, and another set of consumers process message in batch mode. Yeah, so that they actually I think that's where they are making that distinction that we were earlier assuming, like in terms of push model. If the rate of consumption falls below the rate of production, we can scale out the consumers or simply catch up when it can. The pull model is more suitable for batch processing. In the push model, the broker has no knowledge of whether consumers will be able to process messages immediately. If the broker sends one message at a time to the consumer is backed up. The new message will end up waiting in the buffer. A pull model pulls all available messages after consumer's current position in the log or up to the configurable max size. It is suitable for aggressive batching of data. Yeah, so I think this is one like this is a good point. A pull model pulls all available messages after the consumer's current position in the log or up to the configurable max. It is suitable for aggressive batching of data. Cons. When there is no message in the broker, a consumer might still keep pulling data and wasting resources. To overcome this issue, many message queues support long polling mode, which allows pulls to wait a specified amount of time for new messages. Based on these considerations, most message queues choose the pull model. Figure shows the workflow of consumer pull model. Join consumer group 1 and subscribe to topic A. Coordinator, okay, so this is broker 1, topic A partition to broker 2. So a consumer joins the consumer group 1 and subscribes to topic A. Partition 2 dispatched, fetch messages and process data and commit offset. Okay, so basically whenever a consumer joins, the coordinator will try to route it to a specific partition, and whenever it knows about the specific partition, it will try to go to that partition to fetch the messages, and after fetching the message, it will try to commit the offset. So that's why that's what the pull model, like that's what this diagram says. So a new consumer wants to join the group 1 and subscribes to topic A. It finds corresponding broker node by hashing the group name. by doing so, all the consumers in the same group connect to the same broker, which is also called the coordinator of this consumer group. Despite the naming similarity, the consumer group coordinator is different from the coordination service mentioned in figure 4.8. This coordinator coordinates the consumer group, while the coordination service mentioned earlier coordinates the broker cluster. Yeah. So this basically this is just a single point of connect for all the consumers. So that's why it's called as a coordinator. Instead of connecting to all the partitions separately, our consumers could just go to the coordinator coordinator of broker, and then it will like try to reroute it to the particular partition. So that's the routing part is basically being done by the coordinator node. The coordinator confirms that the consumer has joined the group and assigns partition 2 to the consumer. There are different partition assignment strategies including round robin, range, etc. And then consumer fetches messages from the last consume offset, which is managed by the state storage. Consumer processes messages and commits the offset to the broker. The order of the data processing and offset committing affects the message delivery semantics, which will be discussed shortly. The order of data processing and offset committing affects the message delivery semantics. Yeah. Any questions, anyone so far? Yeah. So I think at least this is straightforward, and yeah. Just the only confusing line I found so far was this: a pull model pulls all available message after consumer's current position in the log. So I'm assuming that the consumer's current position in the log is nothing but an offset that they are trying to point to. So if it is pulling in batch, it will try to pull, let's say, number of messages ahead of offset, and if it is trying to pull number of messages ahead of offset, then they are saying that it is called as aggressive batching of data.
There
But
was
why is it?
some state storage, huh?
I think state storage is nothing but what Praveen was talking about, I believe. Like, but yeah, I think it will come ahead. Like, I think, but yeah, I think I think this is much related to the offset commit part. Yeah, this is it.
Yeah. Yeah, we'll go through it later.
Yeah.
I think it's in the description.
Okay, yeah. So, any questions around the pull model? Okay, yeah. Yeah, we can start from consumer rebalancing tomorrow.
Well, thank you.
Yeah, thank you. Thank you, everyone.
Thank you.
सागर
Yeah, same.
मैंने लेट ज्वाइन किया था. What was discussed?
So we discussed earlier. We were discussing the push model. So actually, we ran into some some doubts related to the push model, like how would the push happen in terms of batches. So if the broker is pushing in batch, how would the acknowledgement and how would the offset commit will take place. So that's where most of the discussion happened. I think you joined somewhere in the middle. Yeah, but before
I
that we didn't
joined
discuss much.
before pull. So
Yeah.
how would it take place? Like if we are doing it in batch, like just a brief about it.
Yeah.
Good question, Haseem.
Yeah, so let's assume, like, I think we were assuming too much of there were too much of assumption. Let's not think about batches at this moment, and it will be all easy.
Okay.
Consider that the broker is sending a couple of messages, and if those are acknowledged by the consumer, then it's fine. If it doesn't get acknowledged, the broker will try to resend those messages.
Okay.
That's it.
Actually, Sagar, there is no batching in the push model.
I am suspecting so, but I need to go back and check it once. I might have some issue, misunderstanding, but yeah, even I believe that there is batching in push model too, but need to confirm once.
Okay, and can we go back just?
Sure.
So in the pull model, there is the first point, pull model pros, consumer controls the consumption rate. We can have one set of consumers process messages in real time and another set of consumer process messages in batch mode.
Mhm.
So what does this mean?
So real time is nothing but one by one, right?
Okay, so are these going to be the, I mean, so let's say we have one consumer group. So whatever consumers we have in that, are they all going to be in the batch mode, or are they all going to be in one to one, or uh, I mean, they can be anything.
Now, in one consumer, if one consumer group is configured to process it in real time, then every single consumer out of it will be connected to their respective partition. Okay, so
Okay.
I'm assuming that you follow that one consumer in a consumer group will be connected to one partition only. You are following that, right?
Yeah.
So if one consumer is uh, basically subscribed to a particular partition, then it can try to pull in just one message at a time for that particular partition. Okay.
Okay.
And now let's say this consumer group is nothing but something like uh, billing service or something like a order management service, let's say, or billing service. Okay. Now there comes a separate service called as accounting service.
Okay.
Accounting service is very fast. So
Okay.
any consumer from the accounting service processes
Can
messages
pull
really
in the
faster.
batch.
Yeah, so any consumer from the accounting service can try to subscribe through a batch mode, and it will always try to pull 10 messages at a time.
Oh, okay.
So by default we are assuming that the offset will be separately maintained for consumers from consumer group 1, and it will be separately maintained for the consumers from consumer group 2.
Okay.
So
Do you know any real-time example of push and the pull model?
I think notification are usually the push models,
Yeah. Yeah.
and pull model is something like our I think timeline service, our Facebook or like timeline or
Okay.
Instagram timeline is a pull model.
Okay.
These are very crude examples, like very like simplest example. There could be more complicated example to pull model, push or push model. But to me,
How
like,
about the logs and all in the like we have log aggregation, all those services, right? We pull logs in the Splunk and all. So
yeah,
does that also is
yeah,
that also
there are both, even in Splunk login there are two modes. If you have a sync, then in sync you can try to basically um, store all the logs, and from sync it will keep pulling the logs, and there is a possibility where your application code can directly push the logs directly to the so I think there it's both, like both push
okay?
and pull works there. So there are these sidecars, right, like Kubernetes sidecars where the logs
Hmm.
go. They can be configured both in push and pull model. So Splunk supports both
Okay.
actually.
Okay.
Yeah, there is actually a separate like like separate design question here in the same book, like separate chapter actually, the matrix aggregation. There they
Uh-huh.
are actually discussing both of these, pull and push in matrix aggregation.
Okay.
So generally the matrix aggregation is a very high scale thing, right? Like the scale would be too high. So so in some cases they try to implement the push part, and some cases they try to implement the pull. Like some part of the design will be push, some part of the design will be pull.
Okay. And can you scroll up?
Yeah.
Yeah, up. Yeah, up. Uh, Yeah. Up. Okay. Yeah. Here. Uh, yeah. If you scroll a little bit up, so this is batching, right?
Mm-hmm.
Um, so I know those 2 points are a little blur,
Mm-hmm.
but uh, yesterday you were trying to describe this. The second point, which says the broker writes messages to the append logs in large chunks, which leads to larger blocks of sequential writes and larger contiguous blocks of disk cache maintained by the operating system. Both lead to much greater sequential disk access throughput.
Mm-hmm.
Can you explain this point?
Yeah. So the broker writes messages to append logs in large chunks, which leads to a larger block of sequential writes and larger contiguous block of disk cache. So what this means is, recently, I think some time ago, I think Praveen was talking about the fat file thing, right? So let's
Hmm.
say if we let me give like a crude example. Let's say if you are writing the messages to a single file,
Hmm.
and then you tries to put that file into the disk.
Hmm.
Consider your block is as big as a fat file. I'm just taking some random example. This is not actually the exact thing, but just trying to abstract this. So you store some logs in a single file, like, and then tries to store that single file in a memory. So if you're trying to store a single file, let's say if it is stored as one complete block of memory.
Hmm.
Okay, so consider that the disk is fragmented in segments. So your this fat file where you stored like the messages in a single batch, it gets stored as a single segment. Okay, so
Uh,
now the all the messages numbered from, let's say, 100 to 200 are getting stored in a, let's say, same fat file, and that file is stored in a same segment.
what is segment?
Segment is nothing but a block of memory. So
And
you
what is block?
a block of memory, basically whenever you write any data on the disk, it always tries to batch together and writes a particular block of data onto the memory. Okay, does that, are you following this?
No.
Okay, so whenever the,
So
sorry.
when you actually you have to sorry, Sagar, sorry to interrupt you.
Yeah.
Yeah. So when you have to write your data on the disk, so have you heard that the concept format the disk, right? And the file system format, right?
Uh-huh.
So how it really it writes that. So it make, so like, in a layman terms, you can say that when you have a plain land and you want to put some homes over there. So you make a plan and you have everything, say like what is the road number, road name, house number, everything. The same way, your OS actually format the disk and create the tracks. Within a track, it creates the segment, and then within a segment, it creates the block, right?
Okay.
So when you write some data, so it write to a particular block, but how you identify that which block, right? So
Uh-huh.
that has that, okay, the block belongs to this track, and within this track, it belongs to this segment, and then there is a block. So how it actually read that offset, when you say that offset in the file, that has that encoded information to reach up to there.
Okay.
Yeah. So this is what they're talking, and when they are talking about the sequential, right? So depends on your file system. So what is the smallest data it can read and write from the disk? So when you say that, okay, I want to read 1 byte, so it does not mean that it will read only 1 byte. Depends on that what is the minimum size it can read, and the operating system works based on that what is the block size. So they can read and write a block at a time.
Okay.
So if your block size is or page size is 4K, so even though you are thinking that you are just writing 1 byte, but underneath it's actually writing 4K
Okay.
and reading 4K when you are just want to read. So that's why they want to. That's why I mean the OS actually buffer some data and then write that 4K in one chunk. But if you recall that when these files in your normal process you read write the file, when you write a file it does not actually flush the data immediately. You have to sync the file if you want to write immediately.
I see. Okay.
Yeah. Otherwise it will keep that data in the buffer and wait for that. If someone wants to write in the same block, then it will flush it.
Okay.
So when you
So
do this sequential write, so append only, most of the case this is append only, so that you don't need to see, go back and forward. You're just moving forward in one direction. So
Okay.
that definitely give you the edge and better throughput. So you sequentially write your data. To you, Sagar. Go ahead, please.
yeah, so just to add to the Praveens point, if we keep our batch size equal to that 4K size, then within a single read write operation, we are importing and storing the whole batch.
Okay.
So you don't need multiple read write, or you are not wasting the read write uh, transaction by just writing half of the messages, just quarter of the messages to the 4K size. So what they are saying is this 4K is a block size. If you keep your batch size same as that, then you are essentially increasing the throughput.
Okay. Okay. Got it.
So what they are saying is, in terms of smaller batch size, that buffering won't be there, like that Praveen was mentioning. It will store it faster, but the disk performance will suffer, because now in within a, like, where you like in one go you have access to the 4K, but you only stored 100, let's say 100 bytes to it. So that's a smaller batch size, so you didn't actually wait for the messages to be committed or stored. You just immediately, you had 100 bytes, you stored it, but that actually caused the disk performance to go down.
Okay. If the batch size is small.
It could be due to small batch size, or you take longer, or it could be due to a fragmented data. Like in a block of 4K, you are just storing one
Got it.
100 bytes, so that means
Yeah.
there will be so many blocks will be used, which are underutilized basically.
Okay.
Does that
Yeah.
answers your question?
Yeah.
Okay.
Thanks, Sagar.
Yeah. Praveen, do you have a minute?
Yeah.
Praveen, actually, I wanted to discuss, like earlier we were talking about Cassandra and the other topics as well, right?
Mhm.
So I was thinking, if once a week if we could go about the advanced topic, and rest of the time we could continue with the Alexu discussion that most of the folks are doing. Uh, so would you be interested in like going for the advanced topic once in a week?
Yeah, I can try to join, but I mean, can't commit that, but I will definitely try to join if you can just let me know
Sure,
the
sure.
days.
Like,
For not Tuesday and Wednesday.
okay, okay.
Yeah.
Yeah, how about Thursday, or like just
Thursday, I think okay.
okay.
Say,
So generally, I think Thursdays, maybe just once in a week we can go about this. But in that case, we will just try to read faster and keep the discussion time low. So in that case, like, we can try to cover the like so one thing I wanted to cover was DynamoDB, AuroraDB, or CassandraDB, one of the DB.
Mm-hmm.
So we can probably read the research paper, or like basically the any of the paper, or we can also read uh, the any other resource. I think we were talking about the educative.io one as well, right? So not sure like whichever is the preference. Educative would be slightly easier. um, the papers could be slightly tougher, or like difficult to comprehend, but yeah, so at least one
Yeah,
run.
paper require.
Sorry.
Uh, if I mean reading paper require, I mean more
Yeah. For sure, yeah.
big commitment.
Correct.
That I mean self study and more discussion.
Yeah, it makes sense, makes sense, yeah. So in the, actually few other folks were also interested, like Aditya, Srini, and like couple other folks, but
Mm-hmm.
since our current discussion was like on a very basic topic, so they said like we can start it again, but they are very much interested if we can do it once in a week.
Yeah, we I can join. Yeah, Tuesday and Wednesday.
Okay.
Thursday is fine if
Yeah.
that.
How about tomorrow?
Yeah, tomorrow is Thursday, right? Yeah,
Yeah.
so maybe we can try to have so I would ask the rest of the folks if we can have two separate ones, or if they would want to part of this one as well.
Anything is fine.
Yeah, so maybe we can try to go about between 6 to 7. We can read one of the uh, uh, paper, or one of the topic like DynamoDB and stuff, and then from 7 to 8 we can have we can continue with this
Yeah, sounds good.
current thing.
Yeah. Do you know what we will read tomorrow? Should we read ahead or we read
Yeah, so
7 or?
do you guys have any preference, Praveen, Ani?
No, I don't have. I mean, whatever. I mean,
Yeah, in
you.
that case, I wanted to actually have a read on Cassandra.
So we'll go through all the databases, right? Basically.
Yeah, so yeah,
Okay, that'll be good.
yeah. So we can directly start with Cassandra, like the white paper, and then maybe after reading, just having a one run through that, we can come back to the basic Cassandra thing, where others can also follow us through the educative one. But before that, I wanted to have one run through the Cassandra white
Yeah.
paper. But I'm not sure whether we'll be able to complete this within a within 1 hour or not. But yeah,
Oh
let's.
no, for sure not.
Yeah.
I mean, to be honest, I mean, for paper, I would say that if you want to discuss the paper, so you should actually one should read it ahead of time and
Okay.
then get involved. Otherwise, I mean, you will just finish 1 or 2 page, not more than.
How about if I can take a I can try basically read it and try to explain as much as I can. If
Yeah, even in that case, Sagar, because you know that I mean these papers are for big system, but very very dense.
Yeah, correct. So you
So
mean like what would you suggest? Like breaking it down, or just going with something simpler?
no, I would say that I mean whoever is actually interested to do that, so they should read paper in advance.
Okay. Okay.
Yeah. So I don't think so. It's going to work. Say like reading during that 1 hour,
Mm-hmm.
uh, for sure will not work.
Okay. Okay.
We can read it and then come with
Yeah, so whichever
the
paper we are
query. That'll be
reading,
more useful.
um, can we put the link to it on WhatsApp so everybody in the group. I think some dropped out already, right?
Yeah.
Some people.
I can put the
Yeah.
uh,
Put the link and say read ahead so that way we can discuss it or
yes,
something
yes,
like that.
yes,
So
yes.
people know. Thank you. I think that will be great.
Yeah.
So we'll do 6 to 7. You do the regular.
6 to 7,
Alex,
let's
and then
do the paper reading, and then 7 to 8 we can do the regular.
okay, 6 to 7 the databases. Okay,
Yeah.
paper reading. Okay,
Yeah.
okay, sounds good.
Okay, perfect.
Thank you.
Thank you.
Thank you.
Thank you, everyone.
Thank you.
Hello.
You can stop recording.
Both.
Bye.
हेलो.
हाँ बढ़िया कभी आएगा हाँ
अभी जाना है या नहीं जाना बता.
यार भाड़ा वो तो 8 बजे तक ही होती ना चांटिंग